Hello, welcome again. We are covering the topic Centrifugal Compressor for Civil Services Mains, IFS and Gate Aerospace exam. And in this, we are covering subtopics compressor characteristics. And we have drawn the compressor characteristics between pressure ratio and non-dimensional mass flow rate for a particular speed. And we studied that this is the region of instability, and the, we studied one more phenomenon, that is rotating stall, which puts limitation in the compressor. Now the third limitation that is put um, in the compressor is in the range of VC, and this is your choking. So this is according to the maximum mass flow rate. So if the compressor is operating in this region, and if we increase the mass flow rate to like this, then the pressure ratio will decrease. So if the pressure ratio decreases, means final pressure is decreasing. If the final pressure is decreasing, then the density is also increasing. But we have increased mass flow rate, so it means the radial component of velocity must increase. And if the radial component of velocity is increasing and the speed is constant, n is constant, because we have drawn this curve for a particular speed, if speed is constant, then your u will be constant. If u is constant, then cw will be constant, but cr is increasing. So cw is constant but cr is increasing. We have more c2, but c2 has some limitation. It can have some maximum value, so it cannot reach, it cannot be above that limitation. So that so there will be a particular condition for which the mass flow rate is maximum. So suppose that point is your E point. So here the CR is maximum radial velocity, CW is constant corresponding to this, so C2 is maximum. So above this the value of C2 is not possible, and means more mass flow rate than this is not possible. So this is called choking. Okay. So I will read this out, and it will make you more understandable. In hypothetical constant speed curve ABC is characteristic curve. There is another limitation to operating range between B and C. So now we'll talk about between B and C. So as the mass flow increases, the pressure decreases. Here if we increase the mass flow rate, then the pressure ratio decreases. Pressure ratio decreases means final pressure is decreasing. If the final pressure is decreasing, the density is also decreasing, the density is reduced, but the mass flow rate is not, as mass flow rate is radial velocity into area. So area is constant, so radial velocity has to increase the mass flow rate, because density is reducing. So radial component of velocity must increase. Okay. So now we have drawn this for a particular speed. This is for particular speed. So now our speed is constant. It means n is constant. If n is constant, then u is also constant. That is pi dm by 60. Okay. If u is constant and slip factor is constant, then cw is also constant. World component is also constant. So, but we have increased radial component. So it means our resultant velocity will increase. Okay. At constant rotational speed, this must mean an increase in resultant velocity and in angle of incidence at the diffuser being leading edge. Okay. So it will increase your C2 as well as angle of incidence, but it has some limitation. Okay. Sooner or later at point E, the position is reached when no further increase in mass flow can be obtained and choking is said to have occurred. Okay. So at point E, the choking has been occurred. The point represents maximum delivery obtainable at a particular rotational speed for which the curve is drawn. Okay. So if we take this curve, Okay, then this is your surging point, this is your maximum efficiency point, and this is your choking point. So if we take this curve, this is your surging point, this is maximum efficiency point, and this is your choking point. This is called surge line, this is called locus of maximum, and this will be your choking line. Okay. So the point represents the maximum delivery obtainable at a particular rotational speed. This point represents the maximum delivery obtainable at a particular speed. Other curves may be obtained. Other curves means this curve, this curve, this curve may be obtained, so that actual variation of pressure ratio over a complete range of mass flow and rotational speed will be shown by the curve as in figure. The right hand side extremities, so this is the right hand side extremity, represents choking. So these represent choking. Okay. The temp. So this is about pressure ratio versus non-dimensional mass flow rate for a constant speed. Temperature ratio will also have same type of curve, so we will not draw this. The temperature ratio is a simple function of pressure ratio and isentropic efficiency, so that form of curve for temperature ratio plotted in the same region, so there is no need to draw a separate diagram. Pressure ratio versus mass flow rate, non-dimensional mass flow rate, and the temperature ratio versus non-dimensional mass flow rate will have similar type of curve, but this efficiency versus non-dimensional mass flow rate for a different speed will be like this. So here we can see that this is your maximum point, this is the maximum point, this is maximum point. So maximum point is almost same for all these curves. From these two sets of points, the curve isentropic efficiency may be plotted as shown in figure B, or alternatively counter lines of body's efficiency may be superimposed as shown in figure B. The efficiency varies with the mass flow at a given speed. So here we can see that efficiency is maximum at point B, so it is varying with the mass flow, and if we vary speed, then it will also vary. The efficiency varies with the mass flow at a given speed in a similar manner to pressure ratio, but the maximum value is approximately same for all. A curve representing the locus of points for maximum efficiency can be obtained by dotted curve A. Ideally, the gas turbine should be so designed that compressor will always be operating on this point. So this is the curve of maximum efficiency. This is almost same for all the rotational speed and non-dimensional rotational speed. So, and the gas turbine should be operated, or when compressor is part of gas turbine, the compressor should be operated on